Hello, the text of this video was manually prepared by Sînică Alboaie from Axiologic Research and is being read by AI. Welcome to our presentation about the potential to build a decentralized version of EPCIS based on OpenDSU concepts. The Data Sharing Unit (DSU) concept is as fundamental as familiar concepts like files, zip archives, or remote procedure calls (RPC). However, it takes time for new ideas to become widely known, especially if they don't come from major companies promoting them, but from academic research projects. To understand the power of the DSU concept, we will engage in an imaginative exercise to envision a future for the EP standard that is properly decentralized to benefit from blockchain technologies in the right way. Currently, EPCIS assumes the existence of some central repositories, and all usage of blockchain looks like a forced afterthought that adds some marginal benefits but betrays the core value of decentralization that relies on digital sovereignty and proper data segregation. The DSU solution also avoids the usage of ZKP, zero-knowledge proofs. While in reality, DSUs are more like a method of implementing the ZKP idea, but in an interactive way. If you are hearing about DSUs for the first time now, I invite you to check other presentations from the OpenDSU YouTube channel or visit the opendsu.com site. Let's now explore how OpenDSU can help us build a decentralized EPCIS for supply chain enterprise blockchain use cases. At a very high level, the purpose of EPCIS, or Electronic Product Code Information Services, is to offer a GS1 standard framework for creating and sharing visibility event data, both within and across different enterprises. This data enables companies to have a unified view of product movement throughout the supply chain. Central to EPCIS is the concept of visibility data, which refers to the information collected and disseminated using EPCIS to enhance the tracking of goods as they progress through the supply chain. A key element in this system is the EPC, Electronic Product Code, a unique identifier for each item in the supply chain, functioning similarly to a barcode but with the capacity to hold more detailed information. EPCIS categorizes event data into four primary types: object events, aggregation events, transaction events, and transformation events. These categories help log the movement and status of products at different stages in the supply chain. Object events record instances when items, marked by their EPCs, are noted at a specific location. Aggregation events track when products are grouped together or separated. Transaction events link EPCs to business transactions, such as a purchase order. Transformation events are employed when an item undergoes a state change, like the conversion of raw materials into a finished product. The capture and query interface in EPCIS is pivotal, providing standardized methods for both capturing event data and querying this information. The EPS repository, a central database, stores all EPCIS event data accessible to authorized entities. EPCIS' widespread application in sectors such as retail, healthcare, and logistics markedly enhances efficiency, security, and transparency within supply chains. By enabling a standardized approach for tracking and sharing product information, EPCIS assists businesses in reducing errors, combating counterfeiting, and ensuring product authenticity and safety. EPS provides a robust framework for supply chain visibility, but could face criticism primarily due to its centralized nature and the challenges it poses in generalizing across various industries. Additionally, involving state entities as trust guarantors introduces its own set of complexities. EPCIS's centralized approach to data management is a double-edged sword. On one hand, it offers a streamlined, uniform platform for tracking products throughout the supply chain. However, this centralization raises concerns about data vulnerability and potential misuse. In an era where decentralization, especially through blockchain technologies, is gaining popularity, EPCIS's reliance on central repositories might appear outdated and less secure. EPCIS aims to standardize supply chain data across different industries. However, the diverse nature of these industries, each with unique processes, regulations, and requirements, makes such generalization challenging. A one-size-fits-all approach may not adequately meet the specific needs and nuances of different sectors, potentially leading to inefficiencies or compliance issues. The concept of involving state entities as trust guarantors within the EPCIS framework offers credibility and assurance. This can facilitate standardization and adherence to regulations, providing oversight that private entities alone might not accomplish. However, this involvement can backfire for businesses. State intervention could lead to increased bureaucracy, potentially slowing down operational processes. Additionally, it raises concerns about excessive governmental control and surveillance, particularly in sensitive industries or regions with stringent regulatory environments. While state involvement can enhance trust in the system, it may also compromise the autonomy and agility of businesses. Companies might find themselves burdened by bureaucratic red tape, constraining their ability to innovate or respond quickly to market changes. This tension between maintaining trust through state oversight and preserving business flexibility presents a significant challenge. The concept of utilizing data sharing units, DSUs, as digital twins could represent a significant step in evolving EPCIS towards a decentralized model. This innovative approach involves encapsulating EPCIS events within digital twins, represented as DSUs, and anchoring them on a blockchain. This method not only maintains the core functionality of EPCIS in supply chain visibility, but also enhances it with the robust security and transparency features of blockchain technology. In this model, each DSU acts as a dynamic digital mirror of a physical supply chain entity, constantly updated with real-time data and events. Leveraging blockchain technology, these DSUs ensure immutable record-keeping and traceability, addressing the centralization concerns inherent in the traditional EPI's framework. The decentralized nature of this approach introduces a new level of data integrity and trust among the participating parties in the supply chain. Furthermore, the granular access control inherent in DSUs allows for selective sharing of information. This ensures that relevant parties have access to necessary data without compromising the overall security and privacy of the supply chain information. Integrating DSUs as digital twins in EPCIS not only makes the system more resilient and secure, but also more adaptable to the diverse and evolving needs of modern supply chains. This represents a significant advancement in utilizing blockchain technology to enhance supply chain transparency and efficiency. The implementation strategy would involve creating EPCS repositories, which we will call local EPCS repositories, to signify that they will be used by a single company or associated companies where a trust relationship is acceptable. In a transparent manner, data from the digital twins are anchored in the blockchain and made available for controlled sharing. This will allow interoperability and integration with existing EPCS clients and applications, as well as the security and confidentiality advantages offered by OpenDSU and blockchain technologies. The DSU concept is intricately linked with the key SI, key self-sovereign identity concept. Think of a key SI as both an identifier and a means of accessing the DSU, akin to how a file is accessed by its name or how documents are shared using a URL. When an entity acquires the key SSI, they gain access to the contents of the DSU. Each DSU is essentially a collection of files, functioning like a compressed archive or a network-accessible lightweight file system. OpenDSU enhances data sharing and supports digital sovereignty through data segregation. Typically, the entity that creates data retains it in their off-chain storage, making it accessible to parties with the appropriate access key, the key SSI. A pivotal feature for achieving data segregation is the Blockchain Domain Naming System, BDNS, enabling DSUs to be anchored or referenced across multiple blockchains or distributed ledgers while maintaining system interoperability. With the ability to utilize multiple ledgers, OpenDSU fosters truly decentralized data sharing. Data sharing units, DSUs, transform how businesses collaborate, particularly where security is paramount. Moving away from traditional methods, we're now adopting key S's to control and manage DSUs with varying access levels. Most businesses currently use APIs, heavily dependent on remote procedure calls (RPC). DSUs, however, are shared by distributing key SIs, and the DSUs are reconstructed over the network by the parties with access to these key SIs. Sharing typically occurs via asynchronous messages, but other mechanisms are possible. For example, in supply chains, information printed on packages could be a method to obtain read access to public package-related information without additional communication. If the information from the DSU's digital twin has confidentiality implications, More secure methods for transferring the relevant key SI should be enforced. Therefore, DSUs are typically shared using asynchronous messages, moving away from RPC. Different parts of a business or separate businesses can share a key SSI, collaborating in processes either centrally managed, like orchestration, or distributed among various groups, like in choreographies. Anyone with the key SI can contribute to the business process at their discretion, adding new information, making changes, and maintaining it all within the DSUs. DSUs can also be conceptualized as a new kind of smart contract. Unlike traditional smart contracts that are stored directly on the blockchain, DSUs exist on a secondary layer, off-chain, layer 2, but are always anchored to the blockchain. The main blockchain, on-chain, tracks the overall state of the contract, while detailed data is kept off the blockchain. OpenDSU's use of blockchain technology aims to enhance scalability, speed, and privacy. The discussion on access control will be further explored in subsequent parts of the presentation, but it's important to note that various mechanisms exist for providing granular access control. Our decentralization proposal presents a significant challenge. Data anchored in the blockchain is accessible to any network participant in terms of its existence. Therefore, access control levels require careful analysis. DSUs are encrypted by default with random keys, ensuring their anchoring does not compromise security. However, in many supply chain scenarios, specific information needs to be directly accessible to those handling the package, typically via QR codes or 2D matrices printed on them. If serialization adhered to the highest cryptographic standards, and if QR codes and 2D matrices contain sufficient entropy, i.e. long enough encryption keys, security wouldn't be an issue. Unfortunately, this ideal scenario is not always achievable, as serial numbers, potentially used as entropy, may be insufficient or absent. In such situations, additional key-sharing mechanisms, either interactive or based on pre-shared keys, become necessary. Furthermore, there are instances where certain data must be accessible to anyone, such as a patient scanning a QR code or 2D matrix on a medication package for specific supply chain information. For registered entities within the supply chain, like intermediary companies interacting with and updating the digital twin represented by the DSU, various levels of access, including read and write permissions, are essential. Therefore, these groups must be identified early in each case analysis, and key sharing methods need to be thoughtfully considered. While keys are often shared interactively through asynchronous messaging, as previously discussed, there are scenarios where dynamically generated keys based on previously shared secret information are more appropriate. OpenDSU supports these scenarios, but a detailed analysis is vital and should be explicitly outlined in the initial specifications. Asynchronous messaging offers enhanced security guarantees and enables the collection of audit information about partner activities. However, it may not always be the best solution in terms of system availability. In cases where certain data must be accessible to auditors, a manageable solution is granting them read-only access to the enterprise systems of the companies. In our discussion regarding write access levels to the DSUs and treating DSUs as off-chain smart contracts, we must analyze the concept of a microledger in the form of SVD, self-validating data, that OpenDSU offers to groups with write access to DSU data. It's important to note that this approach introduces complexity. The mere existence of multiple groups with write access may necessitate various SVDs, each with distinct access control, thereby increasing the overall complexity. If there is a non-empty intersection of these groups, additional complexity is introduced. However, hopefully, the realities of the use cases will not lead us into such complexities, and simpler approaches remain possible. The diagram above illustrates the potential to embed self-validating data structures within DSUs, forming a microledger. This microledger could contain predefined business logic translated into a list of signed commands, each authorized by the initiator of the change. This setup requires anyone accessing the data to revalidate it by replaying the commands, trusting only those that are successfully executed. If a command lacks a valid signature, or if the command sequence violates the business logic, all commands associated with that sequence will be invalidated and removed from the microledger. This process ensures data integrity and adherence to the defined business rules. We could envision potential challenges along the lines of system integration complexity, data synchronization and accuracy issues, scalability challenges, adaptation to industry specifics, blockchain complexity, regulatory compliance, cost implications, performance, and latency. However, in our current understanding, the primary challenge will likely lie in potential incompatibilities between the decentralized security model and the EPCIS capture and query interface. Therefore, in the first iteration, creating a web interface that is perfectly compatible with EPCIS may not be feasible. Instead, an interface oriented towards the realities and constraints of the new system will be developed. In the second phase, efforts will be made to accommodate and possibly, through collaboration with GS1, enhance the standard to allow for real interoperability with the current standard. The need for multiple ledgers and securing the digital twin will involve new types of interactions that do not exist in the current EPCIS framework. As we come to the end of our presentation, I'd like to extend a heartfelt thank you for your attention and engagement. If you found this discussion on enhancing EPCIS through decentralized, cryptographic, and digital solutions interesting, we encourage you to explore further. For more insights and detailed discussions, please visit our YouTube channel, where you can access a range of presentations that delve deeper into these topics. Additionally, for comprehensive information about OpenDSU, our website opendsu.com is an excellent resource. We are optimistic about the potential of these advancements to make the world a better place. Particularly in countries where the supply chain is not regulated by the state, our proposal offers a more comfortable and business-friendly alternative. We are excited about the benefits of decentralization, cryptography, and digitization, and are committed to realizing these in a way that is harmonious and positive for everyone involved. Thank you once again, and we look forward to continuing this journey towards innovation and improvement together.